welcome to this session. We're looking at Maths series of books. We've chosen a few pages from different books from year 1, primary 1, all the way to primary 6. So the content of the day is what is an anchor task, pre-lesson checks that you would want to do before anchor task. Then I'm going to go and show you 5 anchor tasks, teacher's role during anchor tasks, and Q&A as well. Give me a second. Okay, we've just noticed a little bit of echo, so we're just trying to sort that out so that there is no echo in the room, so to speak, the webinar room. So let's get started. If there are issues, if you can just let us know. I'm not sure. I can't see any chat features where we can kind of see your messages. So somehow, if you can let us know, it'd be great. Okay, so let's get started then. What is a anchor task? Is something that I asked you at the beginning of this session now. So does anyone have an idea of what an anchor task is? I was hoping that we can have some sort of chat facility so I can see your replies, but I can't see that here. So I'm not sure how you can answer these questions. So let's have a go at going through it then. So an anchor task. You may have heard of anchor task as a different type of name. It might be something that's more common to your region, but an anchor task is a task that we start a lesson with. Okay, so in a maths lesson, let's say we're starting a lesson on fractions, we might ask a question on the board and you'll be expecting your children to have a go at the question. It might not be the case that they get everything right straight away. It might be that they struggle. But in maths, it's okay to struggle. It's okay for our children to struggle and have a go and try to understand the question. And then for us as teachers, we get a chance to see what they're thinking about, how they're thinking, and try to change their thinking to a more efficient way of thinking. So anchor task is a task, a question that we set at the beginning of the lesson. But in the Maths series, you have a lot of visual representations as well in the books. So how do we get around that? Well, one of the things we do is we ask our teachers to use concrete materials to try to show how they can maybe solve this question. So anchor task is a task or a question at the beginning of the lesson. And along with that, we expect our teachers and our children to be able to play around with concrete materials. So what does that mean, concrete materials? So if it's fractions, it might be some paper. It could be, what else could it be? It could be deans. It could also be place value counters. It could be a paper cut up into a shape. So it could be many different things that allow our children to play around with the maths. That's what the paper is there for, or the deans are there for, place value counters are there for, so our children can see the maths. There's a good old saying that if our children are able to firstly play with maths in their hands, then they'll be able to play with maths in their minds or in their brains. Without playing with maths with their hands, it's going to be much more challenging to play with maths in your mind. Okay, so bear that in mind as well. So how does this help then? How does an anchor task help our children to benefit from the lesson and try to understand maths better? Firstly, they're allowed to struggle, they're allowed to play with maths, and then that allows them to have a sound understanding of what's happening as a abstract idea. So this anchor task follows a CPA approach. So the concrete is followed or is shown alongside the pictorial. That leads, both of these lead to the abstract. And so that allows our children to understand maths better. And instead of us just telling them, this is how you do something, guys, okay, instead of just showing them how to do it, we want our children to be able to see the maths and so that they can explain themselves to you. So things to think about when you're giving an anchor task and concrete materials is, how do I support my children that are struggling? And also, how do I extend those who have got the idea, who've grasped the idea? How can I then challenge them further? So before all of that, before we discuss those key elements, we're going to look at pre-lesson checks, okay? So before we have a lesson, we want to have a good anchor task. We can choose many different questions, right? So how do we choose a question that's suitable for our children, okay? So our class can understand the actual content of the lesson and therefore flourish later on. So something we have to think about is, what is that task? And the good thing about the Maths series is that each lesson has, for you as a teacher, has already got the anchor task set for you. So all you have to do is identify as a teacher, plan your lessons accordingly, and therefore it doesn't allow us to kind of waver from that lesson. So we don't have to think about it too much because it's already there for us. The planning is therefore easier for us because there's a lot less planning. We don't have to think about it as much. So what is the task is a question mark. And the way we can kind of answer that question is, it's in the books, okay? But where? That's the question we're going to look at in a bit as well, okay? Where is it in the book? Another pre-lesson check is, what resources do I need? What resources do I need for this lesson? Do I need to have the deans out? Do I need to have place value counters out? Do I need to have paper for lessons? What do I need? Do I need scissors, glue? All of those things are really important to plan your lessons effectively. So having a look in the book tells you also that, oh, it looks like I need the deans today, or it looks like I need place value counters or a place value chart, okay? There are really useful ways that you can show a concept visually. So we want to make sure that we have those ready for our lesson rather than trying to look for it during the lesson. Other pre-lesson checks, we would want to also make sure that we are aware of misconceptions and we plan to show those misconceptions. So I might pretend to my children and say, oh, look what I've done here. Is this right? And if it's right, great. But if you've made a mistake on purpose and you want your children to see that mistake, then you want to discuss those misconceptions as well. And finally, other pre-lesson checks before you start a lesson, when you're planning the planning phase, you're going to want to also think about how to extend your children and how to support your children. So we're going to look at the anchor task today, and we're going to think about different ways we can extend and support our children in different lessons. So our first core essential we want to look at as well is where we talk about, I think if you attended our last webinar, I showed you this screen as well, where we talk about the kind of necessities of a lesson. We want to make sure that our children see the maths, so representation is really important. So things like the deans and place value counters I've already spoken about, these are so important in maths lessons because it allows our children to see the maths and therefore understand the structure of maths as well. And then we've got generalization. Can we get our children to generalize as much as possible in our lessons? Some people actually say that if a maths lesson doesn't have generalization, then it's not considered a maths lesson. So having that in the back of our minds, it's important to kind of think about, where can we make our children generalize in this lesson? So these are two things that we're going to really focus on in our session, as well as communication skills. These three aspects we're going to try to focus heavily on, as well as number sense and metacognition, but those are the three that I want to really focus on today. So here we've got a, so I'll zoom in for you. Here we've got It's not letting me zoom in for some reason. Okay, so here we've got a page from our Max Math series, and you can see we're looking at millions. So it's one of the year groups that are year 5 and 6 related. So these questions, this question is year 5 and 6. So 5,200,000, 6,000, 60,000, 1,943. You can see all of those hopefully here. You can see all of those represented, all of those numbers represented here. You can see there are 5, 2, 3, 4, 5, 5 lots of millions here. So that's 5 million. And you can see how they've represented it here as well. Okay, so you can see how a number, you might think, how do we ever represent 5,261,943? Well, this is one way. We can use something like this, a visual representation like this, or you can use place value counters. It does the same thing. If you don't have something like this in your school, you can use place value counters. And you can discuss how these 5 counters represents 5 million. But we also want to think about, how do I extend my children? How do I start this lesson off? How do I support my children that are struggling? So if in our book we have the Let's Learn Together section here, this represents for us, this is your anchor task. This is telling you as a teacher, this is the anchor task. And this is where we start. Now you might think the answers are already here. How am I going to show our children? Why would I show them this if the answers are below? What I would do as a teacher is make sure that this is covered up, so you don't see this at all. Okay, they only see this. It says, look at the beads below. Can you write the number they represent? Can you write the number in words? So what I might ask is my children to get a mini whiteboard and write down the number they think it represents and the number in words as well. And then talk to them about what they see here. Can they see this? What happens here? We've got 900, for example, right? What happens if I've got 1000 or 1100? How do I write that down? So this 900 here will change, right? If I have 2 more, I'll have 1100. Can you see how 1100 is actually 1100? Can you see how clearly that can be seen by using an example like this? So these are really important parts, right, of our lesson, to know that if there are more than 9 of any of those place value items, whether it's hundreds, thousands, 100,000s, if there's 10 or more, then it goes into the next place value chart, right? So we can show them this with a visual representation and an abstract representation here together to see what happens. Just like children know that when we have more than 9 ones, we have, let's say, 10 ones, then that's 110. That goes into a tens column, right? So this is an example of an anchor task. And this is how we start off a lesson. I would have started off by giving them place value counters, or if I have something like this, that would be brilliant. But if I don't, place value counters is fine. And then I would ask them this question here, and then I would allow them about 5 minutes, sometimes less than that, sometimes more than that, depending on the question. Allow them to kind of answer that question. At the same time, I want to be going around to support my slower learners that might be struggling with this, and support them myself as a teacher, give them the concrete materials to show, ask them, how many millions do you have? Oh, there are 5 lots of millions here. So we write 5 million. How many hundreds do you have? There are 9, so that's 900. So visually, when they see it and play around with maths, it's easy to answer those questions. For my higher achievers, though, you're probably asking yourself, okay, this looks quite simple maybe for my higher achievers. How do I push them further? How do I get them to see the maths that I want them to really benefit more from, right? So what I might ask them to do is I might have some missing pieces. So I might have a missing piece here, and I might also not have the missing piece here. So this is 200,000. So this is a 200,000, right? I might ask them, how many 100,000s will there be there? Okay, can you fill in the missing pieces? That might be one way I extend them. Another way I might extend them is ask them a question like, if I've got 12 hundreds, what happens? Can you write an explanation? When I have 12 hundreds, what should happen in this image? Well, if I have 1200, actually 10 of those, that's 10, 11, 12. If I have 1200, then 10 of these pieces should, 10 of these pieces, try that better, should actually be regrouped into the thousands column. And then I only have 200 here. So I'll have an extra 1,000. So these are like really important things that we need to know in place value, right? But how do I get my kids to understand that? By using visual representation. But then how do I get my kids to then explain themselves? So I might ask a question like, if I have 1200s, how do I show that in this picture? Can you draw a picture of this in your book? Can you write an explanation? What would happen if I have 1200s? So these are ways that I can extend my faster learners who are getting this quicker than others, whilst at the same time, I don't want them to move on to a different lesson or a different topic. I want them to stick to this lesson, but at the same time, I want them to be able to challenge themselves and flourish in the lesson as well. So the second page, you can see here, let's write the number represented by the beads as a numeral and in words. So you've got the first anchor task here. Then you might ask another question just to kind of give the children more confidence. I might ask them a second question. This is number 2, anchor task number 2, right? Again, I would hide this, and it's easy to hide on your screens. If you have online resources, you can just zoom in, right? And you can hide whatever this is. You can hide all of this when you zoom in. And that way, when you zoom out, you can then go through this with the children as well. And then you've got a third question. This is quite a big jump, right? So this is another anchor task question. You've got a big jump. I know it's an anchor task because it's in the Let's Learn Together section. And also, it's also giving me the solution here. So it's telling me the answers. So therefore, I know this is something that is going to be a strategy or questions that will come up later on in the lesson, either in the workbook or in the actual textbook as well, in the student book. So here you can see our children are going up by 10,000. So if you use place value counters, then you can have like 1 million here, and then you can have 100,000, you've got 400,000, and then you've got another 40,000. So you can have all of these, and you can say, what happens? Can you show me what happens when you go from 1,445,206 to 1,455,206? Can you show me what happened with a drawing? Can you show me using a place value counters? And so what you'd want is, oh, there's an extra what here? 10,000. So this is my millions, this is my 100,000, this is my 10,000 column. So what happened there? Oh, there's an extra 10,000. So you can draw that in, color it in, and say there's an extra 10,000. So now I've got 1 million, I've got 400,000 still, but now I've got 400,000, but I've got another 50,000 rather than 40,000. So that's what's happening in this. What's happening in here? Can you use your place value counters to show me what's happening there? Can you draw a picture of one of these to show me in your books what's happening? So you can describe it. Oh, each of these, we're adding 50,000. Let's see what happens when you add 50,000. And you can go through them using this place value chart at the same time. So if you add 50,000, where's the 10,000 column? This is a million, that's 100,000, that's a 10,000 column. So if we're adding 50,000, that will change to 5. If I add another 50,000, what would happen there? Oh, now we've got 10 lots of 50,000. That's 10 lots of 50,000 that's going to be. So we can kind of discuss all of these key elements during our lesson, but using visual representations so that we can understand what's happening and our children can understand that as well. And then you can see that we go on and we have a let's try section. So once our children have a few attempts at these questions and they can see what's happening in each of these types of anchor tasks, then what happens is we have a go at solving some questions. So you can see it starts off quite simple, like the first anchor task, and then it goes on to be a bit more challenging, and then finally you get to write down the number in words, and then you have some sequences that we looked at the end, and can our children work out the sequences? So that would be the lesson. And then some of our children would be able to go into the workbook straight away, and they can go into workbook page 2 to 7, and you have similar questions like these and these, so that they can build on their understanding and they can extend themselves further. So that's our first example of an anchor task, okay? We talked about pre-lesson checks, so things that we need to think about in this lesson. For example, our pre-lesson checks, what would I need? Okay, I need to think about, how do I extend my children? How do I support my children? I would have supported them with the concrete materials. How would I extend my children? Maybe I'll have missing sections, okay? What do I need in my lesson? I need resources, so I need to have either something like this, okay? I can print something like that out easily, and then I can ask them to draw on the printed paper, or I can ask them to use place value counters. That's also very helpful. It's very similar to this as well. I need to think about, how do I question them? I want them to see the link between this and this. So I might ask, how many millions do I have here? I've got 5 millions. How do I write that down? 5 million like this, okay? Misconceptions. What happens if there is no thousands? What do I do there? Do I just miss that number out? Or do I have a placeholder like a 0, right? So you've got that in this question. So there is no 10,000. How do I write that down? There's a placeholder here and another placeholder there, zeros. So these are all types of questions and types of anchor tasks you'll find in our books, where it's very visual and it helps you to understand the maths that we're going to be doing in terms of abstract maths by looking at the visuals. So let's go to another anchor task. Let's say, before we go there, actually, I'm going to ask you a question. I'm going to give you about a minute to think about this. The question is, how would you start to teach decimals? What would lesson 1 look like? So I'm going to give you, I don't know, 30 seconds to kind of think about that, and have a think yourself, maybe write a few things down. Give you about 30 seconds to a minute to think about how you would write and start to write down a lesson plan for teaching decimals. So it's the first time children have seen decimals. Technically, you've never been taught decimals before. They might have seen it in shops, that's fine, but they haven't been taught about decimals before. So have a think about that. I'll just turn my sound mic off. Okay, class. So think about a minute. So if you can just type in, how would you start decimals? Do you have any comments? And also, if you have any comments, not just to how to start decimals, but how you feel about teaching decimals as well. If you've taught decimals this year already, or if you're about to start teaching decimals, or are you looking forward to it? Is it a struggle in your school to teach decimals? So tell me about your experience of decimals and how you think you teach decimals. We're looking at the, if you type in, if you click on the question mark, I think on your screen, if you've got one, and then you can type in your solution, your answer to my question, that will be helpful so that I know that you can hear me and you understand the question. Give you a bit more time. I'll turn my mic off as I wait for a few answers. Okay, so we're back. So generally speaking, decimals are challenging, challenging topic to teach, and especially to begin with as well, because our children can't normally see the links between previous learning and decimals, maybe because it's the way we've showed them as well. Okay, so let's have a look at what Max Math series have in front of us. So here you can see that there are some hints for us to kind of look at. Have a look. Let's see if I can zoom in. I still can't zoom in for some reason. So have a look at this page. Hopefully it's quite clear for you. It says here in the Let's Learn section. So we know already that the Let's Learn section is a hint for us that this is the anchor task. Okay, this is the anchor task. This is what we have to start off with. So by this stage, our children have already looked at fractions, and they've looked at it in a very visual way. If this piece of paper is a whole piece of paper and it's been cut up into 10 equal parts, then this section represents 1/10 of the whole, right? And so how do I then kind of get our kids to think about decimals? Maybe what I'll do is I'll start off using place value chart. So I've got my ones, tens, hundreds, so forth. And then I've got something that's here. Is there anything there, class? Can anything be less than 1? Oh, we can see that there are something less than 1. Look, if this is the whole paper, if this is one paper, then this 1/10 is less than 1, right? And so this section, so when we start to write down our place value chart, we should start to write down that after decimal is the 10th column. But a lot of the times we write down 10th, but we don't connect the 10th to the 10th that we've been looking at in the past, which is 1/10 as a fraction. So class, how many tenths are there here in this picture? How many tenths can you see in this picture here? Can you see, oops, sorry. Can you see that there's only 1/10 there? So what we can say is there are 0 ones, this is not a whole, but there is 1/10. So we say it's 0.1. If I shade in another tenth, how many tenths do you see there? Is this still a whole? Oh, there are 0 wholes, but I can see 2 tenths here. And what about if I shade in 8 tenths? Oh, there are still 0 ones, no wholes. 8 tenths sounds like a big 8, right? But it's not 8 wholes, it's 8 tenths. And the way we write that down is to have 8 after the point, 0.8, and that 8 represents not 8 wholes, but 8 lots of tenths. So this is one way we would want to start this lesson off, because we want to show our children, this is new learning as well, right? This is the first time they're going to be taught this, okay? So you don't have to, in this anchor task, you don't have to worry as much about them trying something out, but I might start the lesson off by saying that this is 1/10, which we represent as 0.1. Then I might ask this question, if I shade in 4 of these, what do you think? How many tenths is that? Oh, that's 4 tenths. How would I write that down as a decimal? Is that possible? And then I might start questioning him in that way, right? And then after that, I could show them this chart. Does the class agree with that? What happens when there's 10 temps? Before I showed them this, I might hide this and say, well, that's 9 temps here. This is 9 temps. What's this? What's that, class? Oh, that's 10 temps. How do I write that down as a fraction? 10 temps. How do I write that down as a decimal? That's a bit more challenging, right? But this is where we need to really pay attention, class, where 10 temps, excuse me, 10 temps is equal to 1 whole. If I shade in all 10 equal parts here, that's equal to 1 whole, right? And so 10 temps is 1 whole. So in the decimal chart, in the place value chart, we write that down as 1.0 or just 1, okay? Because we know there are no extra temps in that picture. Okay, so then the anchor task moves on to slightly more challenging questions, right? What happens when we've got 2 wholes and then we've got 1 temps? How do I write that down? We write that down as thinking about our ones. We've got 2 ones, 2 wholes, and how many temps do we have? We've got 1 temps, so it's 2.1, okay? And you can see the other questions are quite similar in that same vein. We can go through those questions. We can actually, after we go through one, what I might do is I might just show the children this picture and ask them about what that is to them, what they feel that is, okay? How many ones do they see? How many tens do they see? Some children might say that there are lots of temps here. There's 10 temps there, 10, 20, 30, 40, 50, 60, 70, 80, and 86. There are 86 temps there. So 86 over 10. And then we come to a conclusion that 86 over 10 is 8 wholes and also 6 temps. And we write that down as 8 wholes and 6 temps as a fraction, but that can also be written as 8.6, where this is the temps column. So that's just kind of linking our fraction knowledge, which we would have had quite a lot of before we get to the decimal lessons. We would have looked at fractions quite heavily. And then with that understanding, we're linking maths topics so that they can use their understanding of fractions to reason and therefore understand decimals as well. And then we can go on to other questions that you can see that we've left blanks so that our children can fill in. And then they go on to the let's practice section where they have plenty of opportunities to kind of look at misconceptions. You can have a go at misconceptions. This is one that always kind of throws children. What does 10 temps equal to? What about if I have 3 wholes and 10 temps? Okay, what would that equal to? Do we know? Well, 10 temps is another whole, right? So we've got 3 wholes and we're adding another whole. That means that's equal to 4 wholes, right? So one way I can extend my children is ask them questions. So I don't need to have another worksheet. I would always just ask them a question that's more challenging than the others so that they can think about that and then not only solve that, but what I'm expecting them to do is start to write in a written explanation of why this is equal to 4, okay? And that way, they're not only improving their maths knowledge, their understanding of maths, their reasoning skills, but they're also improving their English skills at the same time, all in one question. So hopefully you've seen 2 examples there. I'm not sure if we're going to have time to go through all 5 and have a Q&A session. We'll try our best, but we've got something that we always talk about on our screen right now, the concrete pictorial abstract approach, which I've written down previously as a CPA approach. So in our examples here, we're using this paper for the anchor task. How can I make that concrete? As simple as getting paper. So what I might do is I might get paper like this, and I might give my children small pieces of paper like this, and for them to play around with that. Then they can then draw a picture in their books, and they can draw temps, right? They can draw tenths, fifths, or whatever you want them to draw. In this example, decimals, we're looking at tenths to begin with, so we stick with tenths. Or I might have a printed piece of paper which already has tenths, lots of tenths, okay, it's for them to play around with. And that way they can kind of understand and go at their own pace as well. Instead of drawing out tenths, which can take some time, it can consume your lesson. You don't want to waste time drawing out things, but we want them to understand. So having a worksheet that's already drawn out might be helpful for you. And so the concrete phase is us giving them paper like so. The pictorial phase is for them to be able to draw out the picture or see the picture in front of them and recognize all of these pictures and recognize that these are, and this is the abstract, these are whatever they are, 2.1, 8.6 and so forth. And then they have plenty of opportunities here to have a go, and which leads them to their workbook. Again, it says here, go to the workbook where they'll have more opportunities to solve similar questions. So the key pedagogy, Jerome Bruner's CPA approach, we have to follow the concrete pictorial abstract approach as we do in our books. It's actually in Singapore, the Ministry of Education have made sure that no schools are allowed to purchase books that don't follow the CPA approach. So you have to kind of use CPA approach in the lessons. Here's a more simple question. It's on handling data. We've got Venn diagrams and Carroll diagrams. Let's look at the Venn diagrams for now. How would I start this lesson off? Have a think about that. Give you 30 seconds to kind of think about that. I'll turn my mic off. Okay, class, we're back. So hopefully you've had a chance to kind of read through that, think about the key aspects of our anchor task. So how do we know it's anchor task? Well, all of us should know now that this tells us that it's anchor task. Let's learn together, okay? How am I going to start this off? I might cover this up and ask the children, what do you think? So imagine this is not here. It says the diagram below is called a Venn diagram. A Venn diagram is a way of organizing information. So I'm gonna ask the children, how has someone organized this information into this Venn diagram? Okay, and so some might say, oh, I can see all the blue shapes on the right hand side and all the non-blue shapes on the left hand side, right? Then I might ask, yeah, that's a really good point actually, but is there anything else you notice? Are all the circles are on this side? What about in the middle, where both the kind of circles meet? What about this part here? What does that show? Oh, it shows blue circles, but on the left hand side just circles, and on the right hand side just blue. So these are all the blue shapes. These are all the circles, and in between there might be blue circles. That's where we put the things that are combined. The two outcomes here, blue and circles. This is blue circles, so we put the blue circles here. And then we can maybe start to read. Let's read what they say. So I might give them that question at first as an anchor task, let them have a discussion, show them the picture, let them have a discussion, and then I will kind of talk them through it, and then we can have a discussion about what it says here. Yeah, we're right, actually. That's what it says. Padma sorted shapes into a Venn diagram. The left-hand side contains all circles, right-hand side contains all the blue shapes. The area where the circles cross contains all the blue circles, so the blue and circles. What I might do from here, I might interject actually in my own lesson. I might think, if I feel they're quite confident, great. If I feel that they're not as confident, I might have them create their own Venn diagrams. So I might have some shapes, some other colors, and give them out to my class. And I might ask them to do that on their tables, or I might come up on our board, on our mini whiteboard, or on our actual major big board in front of our class. I might ask them to stick the shapes into the Venn diagram so that they're sorted in a certain way, and then ask them, how did you sort it? So this is just a way of getting them to be more hands-on, to be using concrete materials, and therefore when they get to the pictorial presentation and therefore later on the abstract, it's not going to be a big jump for them. So as we're kind of running out of time, I'm going to go over and kind of show you the fourth, I think, and fifth anchor task as well. So we have at least 5-10 minutes at the end for any Q&A. Please do, ask any questions that you feel, if you don't understand something I'm saying, or if you think it's good or interesting, or you haven't heard that before. Any kind of comments would be greatly appreciated in our question section. Think about any questions that you might have as well for later on. So here we've got another anchor task on area, anchor task on area task. So let's see what it says. It says here, let's learn together. So I'm thinking about planning this lesson. So I'm a teacher. This is not the actual lesson, but I'm thinking about planning the lesson. This is the next lesson in our chapter. It's on working out the area. Okay, well, how am I going to do this? What I want to make sure I have is I want to have some concrete materials. So I might give out shapes, rectangular shapes, to our children. So I might cut some shapes out and I might say, here you go. This is for your table. I want you to kind of think a whole list, and I'm going to give you some questions on it later on. With my children that are struggling, I might already have squares on there, centimeter squares, so it's easy for them to kind of work out. Here it says hand draws a rectangle that is 8 centimeters long and 2 centimeters wide. He then divides the rectangle up into 1 centimeter squares, as you can see here. So what I might do, I might just show them this picture and ask them, can you divide them into 1 centimeter squares? Is that possible on your paper? Get a ruler and try it out. How many squares can you divide your rectangle into? So they might have different rectangles. It just depends on my class, right? I might feel my class are really confident they can do this with different rectangles. Great. I might have different groups of tables with different rectangles. So it all depends on you as a teacher, how you feel your class will handle this. And then we start to talk about quite a formal side of this lesson, right? Where we talk about each of these centimeter squares is called a square centimeter, which we write down using this terminology, right? Using this. And then we're going to talk about these shapes. Can you investigate? Can you write down the how many square centimeters? So here, even though the word area is written here, for my children that are struggling to kind of maybe understand English, and English is obviously not their first language, I might try to make sure they understand that by counting the number of squares, the number of these centimeter squares, once they understand that the number of these centimeter squares represents something, which is called area, that's the key part. I need them to see and feel and play around with the small squares so that when I get to area, they're not bamboozled by that word. They don't feel scared by that word. Area just means to calculate how many of these square centimeters or square meters or square units that are in a shape. Okay, how many of those square units make the shape? And so let's look at these 6 or 5 pictures, these 5 rectangles. Can you then investigate the shape? So I would ignore all of this. I would either cut them out or get them to kind of look at these 5 shapes and then tell you how many of these square units there are for each shape. And then have a look at this. Is there a quicker way, class, of working out how many square units there are? Let's say we don't have these squares in front of us, right? Let's say we're told that this is 4 centimeters and this is 5 centimeters, and we don't have these squares. Is there a way of working out how many squares there are? And so we want them to come to a conclusion that, hey, look, 5 times 4 is 20, 4 times 3 is 12, 5 times 2 is 10, 3 times 2 is 6, 4 times 1 is 4 square centimeters in each case. So a good way to work out the area or how many of these square centimeters there are is for us to multiply the length by the width. And that way we can start to understand questions like these, which are the more challenging questions. So it might take us a while, but we want to go through these types of questions for our children to realize that length times the width is how we can work out the area for any rectangle. And when it comes to a square, it's just going to be the one side multiplied by the other side because they're both equal, right? So if you know one of the lengths of a square, then we know the other widths, I suppose, and therefore we can work out the area. And you can see that the let's try section is the part that we want our children to have a go. We want them to be able to try out themselves without us interjecting. And we also want them, you can work together in groups in the let's try section because the workbook is the fully independent section, okay? Whereas the let's try section, some of our children might want to try it independently, but some of them might still need some reassurance, so they might work with a classmate, and they might obviously work with you as well as a teacher. So another question is, do you find teaching problem solving a challenge? What are the challenging parts of teaching problem solving? A lot of children don't understand the steps that they need to take. So here is another word problem section from one of our books. And you can see that they've got apples and bowls here. So obviously we might not have enough apples in our classroom. So we can use something else. We can use counters. We'll probably speak to a class and say, can you use, does it have to be green counters? Can you use any color? It doesn't matter which color, right? A red counter just represents one of these apples, okay? So here's a question. Tia buys 12 apples from the market. She wants to place an equal number of apples into 4 bowls. How many apples are there in each bowl? And so what I might start to do is get my counters. I might get a cup, okay, some sort of paper cup or something, and I might say, well, she wants to place an equal number of apples into 4 bowls. So my 4 bowls might be 4 paper cups, like so. And I've got 12 apples, so I'll give each class 12 counters, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How am I going to, class, put these 12 counters or 12 apples into equal number of apples into 4 bowls? What could I do? Some of our children might realize straight away 4 times 3 gives me 12. So I'll have 3 here, 3 here, 3, 6, 9, 12, 3 in each of these cups. Some of our children might not see that straight away. So how am I going to get that? I might ask them to share one at a time, right? Have we used all 12, class? Oh no, we haven't. So we continue. We keep doing that. How many have I shared so far? I've got 2 in each cup. We've still got 4. We've still got 4 more. Okay, so let's do this then. And now I can see I've got 3, just about 3 in each of these bowls or cups, and you can see that here. That's exactly what they've done in the let's try section. So let's try section is telling you this is a strategy you can use. You don't have to use apples, but the strategy is to share individually one at a time until you finish all 12, okay? Some of our children might know that 4 times 3 is 12. That's great, but they need to understand how does that help us? Because we're going to see by the end, we saw 4 lots of 3 apples, 4 times 3. So 12 divided by 4 is 3. We can use our times table knowledge to kind of solve those questions too. And you can see a few more anchor tasks here, one of which has the bar model approach, which you can use as well. So we've got the bar model approach in a few of our different books, and we've also got the bar model resources that we've recently got online, and you can also have a look at those as well. And then it goes into let's try section, quite a few questions there. Again, very visual until the end, where you can see that they're not as visual, but then our children should have a better understanding of what's going on and therefore be able to solve those questions in a more abstract way. Okay, so kind of finishing off our session today. Don't forget the key representation. Using concrete pictorial abstract approach is very important. Trying to get children to generalize what happens. For example, one of the questions I spoke about was a fractions decimal one, where I said, what happens if we have 10 tenths? So trying to generalize that whenever we have the same number of numerator and denominator, then it's a whole. Okay, so that's a generalization. Don't forget the CPA approach. Visualization is so important. I can't emphasize that enough, because seeing maths really helps us to master maths, to understand and master maths. So what do you think are the key parts of planning an anchor task for any lesson? Have a think about that. Hopefully it gives you, this webinar has given you plenty of ideas about how to kind of teach using an anchor task, how to teach using our books, what different parts of our books mean, how to use them, thinking about enriching our children with some extension work, and also thinking about how to support our children as well. Maybe what you could do as well, think of a lesson yourself and to teach in the coming days and weeks, plan your anchor task and maybe send it over to us or put it on our social media pages as well, so that you can interact with us and we'll get back to you on those as well. If you have any questions, feel free to email us. You should see a email address here in front of you on your screen, and it's international.curriculum@macmillaneducation.com. So if you have any questions after our session, please feel free to email and we will get back to you as soon as possible. Thank you.